Here we'll implement a queue using two stacks. Let's create the class. We'll call it QS. Open this up. We'll initialize two stacks, S1 and S2. And we'll initialize two variables to 0. Dequeued and count. Now we'll write our enqueue method. I love this one because it's very simple. We simply push X into S1 and increment the count. Let me move this up. Now for our dequeue method. Here we will return the integer that we dequeue. If the stack is not empty, we'll iterate through all of the elements besides 1 and push them into stack 2. So here we're taking the element that we pop from stack 1 and pushing it into stack 2. We're done with this for loop. Now so right now we have all of the elements that used to be in stack 1 besides one element in stack 2. So what we'll do is we'll pop the last element and set that equal to dequeued. Because it was at the bottom of the stack, it's essentially what is meant to be at the front of the queue. So now we've popped our last element. And we need to use another for loop to put everything back into stack 1. So that we maintain the order and so that we don't need extra functionality in our enqueue method. So. This time, I going from 0 until count -1 puts all of the elements back because we've popped one element, which is exactly what we want. So now we do the converse of what we did here, and we put everything back from stack 2 into stack 1. Awesome. Because we popped one element from our queue, we're going to decrement count. And we will return the element that we dequeued. And we'll close off this if statement here. Now we need a situation for when s1.count is 0, so when there's nothing in stack 1. We'll do that using an else, because if s1.count is not 0, that means it's 0. So we'll throw this not supported exception and give the user a little bit more info. Not enough elements. And end that. Bracket off that else statement, and we have, I ran out of space on the paper. Push this up, but we have 2 more brackets that we need to throw in here. One for dequeued. I'm just gonna put them on the same line, even though they would be on subsequent lines, and one for the class. Awesome. So that is our class. Now, on the next page, let's write out our main and some driver code so that we can interact with our class, and we'll discuss what's going on. Okay, so what we're going to do is initialize a new queue of class QS. Because that's what we named our class we've been working on. We'll name it Q. Now let's, we don't want to NQ and DQ too many because I don't want this video to be extremely long, but let's NQ and DQ a couple of elements so we can test out the functionality. Here we call upon our NQ method we wrote. We'll NQ1. Let's NQ two. And let's DQ. So just to check what is being DQ'd, we'll use console.writeLine. We don't need to pass anything into here. And let's NQ one more element. Awesome. So this is our driver code that we're going to work with in our class here. So let's run through what would happen in our code. Bless you. So we have stack 1, stack 2, and we have our idealized queue functionality. So what we're doing is NQing here. That gets thrown into stack 1. We'll NQ again. 2 gets thrown into stack 1. We'll DQ. What happens is, and right now count was 1, and now count is 2. That's a funny coincidence. So we're going to DQ. What we're going to do is move count -1 elements into S2. So 2 goes into S2. It's gone from S1. 1 gets popped and written in the console. So 1 is gone. Count gets decremented. Count is now 1. And 2 gets thrown back into S1. We'll NQ one more element, 3. And 2 was removed here. And now in S1 we have 2 at the bottom and 3 at the top. Let's review the space complexity and time complexity. So overall, the space complexity for this class is O of n. And the time complexity, so the time complexity for NQ is constant, and the functionality for, let's call this NQ, I like that, and the time complexity for the DQ functionality is O of n. Thanks for listening.